Hello. So, today we need to do this question. First of all, we need to draw the diagram. So we have the box, and we have to have the forces acting on it. Now, this is limiting on friction. So, the frictional force is at the maximum it can possibly be before the box starts to move. Firstly, we have the weight of the box, which is an unknown value. So, the reaction to the weight is also an unknown value, acting on the opposite direction to the weight. Now, we also have this force of 12 newtons trying to push the box to the right, and a force of 15 newtons acting at an angle of 30 degrees to the horizontal, in the same sort of direction. So, the frictional force must be equal to the 12 newtons, but when added to that, we must also have the horizontal component of the 15 newtons, which is acting in the same direction as the 12 newtons pushing to the right. And the frictional force, since it's limiting, which means that the friction is completely equal to the force that is trying to move the box against the friction should be equal to those two different forces. So what we need to do is take the 15 times the cosine of 30, which is the angle, which gives us 12.99 approximately. Then we can simply add that to the value for 12 that we have to give us the frictional force, which should be 24.99, so approximately 25 newtons. So with our value for the friction, we can now find out what the reaction force to the weight must be. We are given that the coefficient of friction for this box and the surface it is on is 1/3. This is also known as the mu, the name of the Greek symbol that's used for it. The equation that we have for this sort of thing is F equals mu r. We can rearrange that to find r, which would be r equals F over mu. So with our new rearranged equation, we just need to substitute the values in to know that r must be equal to 24.99 divided by 1/3, which would give us 74.97. Now that we have a reaction force, we can find the weight of the box. So, in order to do that, usually the weight would just be equal to the reaction force, but we have this pesky diagonal force at work again. So the vertical component of that will be acting against the weight as well as the reaction force. So, in order to find what the weight truly is, we must add this force to our value for the reaction force. In order to find the vertical component, we know that must be 15 sine 30. We simply take our value, 74.97, and add 15 sine 30 to it, which gives us a value of 82.47 newtons for the weight.